All right, so we are starting Power BI officially, and we're going to be treating the theoretical part of Power BI throughout today. And if we're able to cover all of that, then by next week, we'll now jump into the practical. That is where it becomes really fun. So I'm going to be bringing up different concepts today. Please just bear with me. Try as much as possible to understand everything I'm going to say. I don't want you to cram anything, just flow with the concept, understand the concept. That's all you need. All right. You don't need to cram anything because when you begin to work with Power BI, you're going to get used to all of these things, all of them. All right. So you're going to get used to all of them just, at a glance. You don't even need to cram anything. All right. So today we are going to be talking about data visualization. Power BI is a visualization tool. Though you've done visualization with your Excel, a part of visualization, just a little tip of visualization, that's what you do with Excel. But Excel is not a visualization tool like our, it's not a visualization tool, so you cannot do any meaningful visualization with Excel because it doesn't even have all the features you need to do your visualization. And that is where Power BI comes in. Power BI is a powerful tool that is designed for visualization. Power BI, there are many tools anyway that we're going to be talking about tonight, but let's start with Power BI. So, what is visualization in the real sense? Let me see. Okay. So visualization is the practice of representing data and information graphically. So you're going to be using different should I call them? Okay, I call them charts. Different tools inside Power BI in form of charts, in form of graph, in form of maps, and other visuals to make complex pattern, trend, and relationship easier to understand, interpret, and communicate. So like we always say, you cannot start showing people numbers. They don't want to see numbers. They don't want to see all of those, your calculations, everything you've done, the tables. No. They want to see these things in pictorial form, in visual. You want to represent whatever information you want to see. You want to see that with charts, with graphs, with maps, different type of charts, different type of graphs, different type of maps that are going to be introduced to in this course, okay? So you use visuals to communicate. Can you still hear me?
Yes, sir, I can hear you, sir.
Yes, I can hear you, sir.
My this thing has stopped.
Loud and clear.
Oh, I don't know what was going on. This is not how my voice is supposed to sound. My Let me plug it.
No, sir, it's sounding the same as usual.
Eh? You say what?
Your voice sounds faint now again.
Yeah, it's faint. My sound system is just having problem tonight. So, but let me charge it a little. Let's continue. Can you hear me now? Just bear with me until like
Yes.
30.
Yes, sir, we can hear you
All
clearly,
right,
sir.
so good. So good. So you represent those information using visual because you cannot use other form of like you cannot use numbers, you cannot use uh give me a second. A lot of things are malfunctioning this time. And I don't know why. Okay, so can already see. Okay. Okay, these are visual. Let me come back to the slide. So you use your visuals to communicate to non-technical audience. It combines design, data analysis, and storytelling to review insight quickly and support informed decision making. So Power BI helps you to use different charts to actually communicate information. Remember when we use bar chart in Excel, that is exactly what we are talking about here. So instead of showing those numbers, you're now using charts to show those numbers. And when you see that we are making more sales in this region and making less sales in this region, it helps the management to make an informed decision from the data you're presenting to them through visual. So additionally, visuals provide an excellent way for employees or business owners to present data to non-technical audience without confusion. So this is the same thing that we've been saying. Basically, it's just to present data and information to both technical people and non-technical people without confusing them. All right. So as we proceed, we're going to see more of this, and visualization tool that we use in data analysis. There are many of them. There are so many of them, but the most popular ones are these three that you're seeing here. The very first one is your Microsoft Power BI, which is the most popular one for so many reasons. It is more simple, like it's simpler to use, and it's even free of charge. The Power BI desktop you downloaded, did you pay any money to download it? Did you do any subscription? I guess the answer is no. But if you try to download other ones like Tableau, Tableau is paid. You have to pay for Tableau. So Power BI is absolutely free. It is more user friendly. It is simpler to use and all that. Then you also have Tableau. Tableau is actually for most persons that are now moving their visualization to Power BI. Most people that were using Tableau, they're now moving. Most companies are now moving to Power BI. They're hiring Power BI experts to come and move their reports from Tableau to Power BI. But however, Tableau also has its own advantages. There are so many beautiful things. Maybe one of these classes will just, practice something with Tableau so that you can see how, or maybe during your internship, actually, you're going to use Tableau to solve a project. All right. So I can see how it will, because you cannot limit yourself to just Power BI. You have to know how to use all of these tools, even though you may be using Power BI mostly in most of the companies. But some companies, I've done a project that we used Looker Studio. I've done a project that we use Power BI. I haven't done a project that we used Excel, only Excel to visualize. All right. And then this is Tableau as well. Then Google Looker is also free of charge. Is a Google tool. You can connect your Google Sheet to your Google Looker Studio, and then it's just exactly like Power BI, but that one is online. Power BI is offline, like you downloaded it in your system, so it's on your is in your desktop. But Tableau you cannot download, it doesn't have an app. It's just like your Microsoft 365, like your Excel online. So everything you're doing on Google Looker is going to be on the web, all right? So, but these are basically the three most popular visualization tool that you're going to be using in data analysis. And the most popular one of them is Microsoft Power BI. So now, variables. I want to talk about, let me see if I can go to Excel. Okay, where is my Excel? It's open. Okay. So I wanted to talk about variables. I want us to look at variables. So I bring you back to data. Remember this data. I think I just created this data recently. This is a data that contains the name of students, the country they came from, then the age bracket, their age, then their zip code of their country, then the scores they scored in the exam, and of course, their grade. This grade is gotten from the score that they scored. All right. So this is just the information I want you to get in this table. This is a data, right? So now variable, these are different variables. The variables here are the student names. The variable here are the country that the student came from. The variable here are the age of those students. So these things are different variables, okay? Now let's look at what is a variable and why do we need to talk about variable in the first place. I wanted to open the other one, this slide. So in order to choose an appropriate plot type or method of analysis for your data, you need to
I don't
understand
know.
the type of data you have. Just like I mentioned now, you need to understand the kind of data you have so that you can know how to begin to work on the data. You understand? So the first rule of clean data states that each variable must form a column. Remember, when we were talking about the rules of data integrity, this means that each column should measure only one underlying feature. You should know that. So each column here is talking about one thing. This is the student's name. You understand that the data here is talking about students. So this column is talking about only the name of the students. You cannot see the age of the students here. You cannot see the country of the students. Then this column is so each column must be talking about one variable of that data set. Here is talking about the age of the student. You cannot come here and see the score or the name or the country of the student. Each column must be talking about a specific variable. That is what I wanted you to understand about variable. So we talk about type of variables. When you look at the data set, there are different type of variables. Basically, two type of variable. Every data set must have these two type of variables called the quantitative variables and the qualitative variable. So the quantitative variable and the qualitative variable, I can also call this one categorical variable. So whenever I talk about categorical variable, I'm also talking about qualitative variable, just so that we don't confuse the quantitative and qualitative. Quantitative variables and categorical variable, that's how I'll be calling them henceforth. So let me explain what that means so that you don't get confused. So when you come to your data set, the quantitative, let's talk about quantitative first. The quantitative. So the quantitative, you're talking about quantify. You can quantify something. You can quantify, like, I don't know, quantitative, quantify, like, I can aggregate. Anytime you see a quantitative variable, it means you can perform aggregations on them. So these are quantitative. This is a quantitative variable. This column now, this variable here, because you can perform, you can get the total number of age here. You can get the total age of students here. You can get the average age of students. You can get the count, the maximum age and the minimum age here. So they are quantitative. You can add, like you can add this age plus this age can give you an age. So anytime you see numbers, not always though, anytime you see numbers, then you know that they are quantitative, like you can quantify them. What is the quantity? Kind of, what is the quantity of the students? Or what is quantity means what is the number of students here? What is the total number of age of students? So it is quantitative. All right. So which other column here is quantitative? Look at score. You can get the total score of students. You can get the average score. You can get the maximum score. You can get the minimum score, right? So this is a quantitative column. The data I have here is quantitative. The one you have here is quantitative. Then how about the grade? It is not quantitative, but it is categorical or qualitative. But I prefer to use categorical. So this is a categorical data. In categorical data, you cannot
Nothing,
perform aggregations
brother.
on them. This is categorical.
I have anything with that.
Nigeria.
Hello, sir. Excuse me.
Okay, go ahead.
Yes, I wanted to find out what's on the screen because I've had one screen for a while. So I'm wondering if it's my network here, it's not moving. I have the one which has notes on variables.
Okay.
I've
Can you?
unmuted many times to say this, but since you did not hear me, we can't see the.
Oh, sorry. I am sharing my Excel. My Excel. Can you see my Excel now?
Yes.
Yes, now
Yes,
it has
you
checked.
can say it.
Oh, so sorry. So sorry. So I was
Yeah.
talking about variables. I said Variables are the data that you are considering in each row, the data that you're looking at in each row, you are considering. So there's a rule that you must follow, which says that each column must contain one variable. Each row must contain one variable. And I've showed you that in Excel, that each row here must contain one variable. This is student name, this is country, this is age, this is data, zip code. So the variable here is student name. It must contain student names. You cannot see the student age here. You cannot see the student score here. You cannot see the student's grade here. This place talks about the student country and it contains only countries. I think we've talked about this one some time ago. So variable, the rule of variable is that each column must contain just one variable. Each column must contain one variable. Since each column contains one variable, these variables are now classified into two major parts, which is the quantitative variables and the qualitative variable, also called categorical variable. Because this is, in fact, every data set you come across has these two type of variables. Every data set is either a qualitative or categorical. Sorry, is either a quantitative or categorical variable. So what is quantitative variable and what is categorical variable? That is what I'm now talking about. Quantitative variable, the first one, is a variable that can be quantified, quantity. You can add them, you can perform aggregations on that column. Once you can perform aggregation on that column, that means it is a quantitative variable. You can perform calculations, you can perform additions, you can perform multiplication on them. Like you can add the total age of students, you can calculate them, even though it doesn't make any sense, but it's possible. You can get the average age. You can say, okay, the students in my class, let's do the average age. You can do equal to AVG, average, good. You can say the student in my class on the average is 21 years old. They can be 22, they can be 23, they can be 19, but the average age of my students is 21. We can do maximum. What is the maximum? What's the highest student in my class? Highest students here can be maybe 24. You can also do what is the minimum. What is the smallest student in my class? Who is the youngest student in my class? You can also get that. It is quantitative. You can perform aggregations. The same thing, the next data that is quantitative here is the score. You can get the highest score, you can get the lowest score, you can get the average score, you can get the total score as well. So this column, this variable here is quantitative variable. Do we understand this, please? Does anyone understand?
Yes, sir. Yes, sir. It's
All
clear.
right, great. So let's now move to categorical. So if a variable or a column does not contain quantitative data, it automatically contains categorical data. So I want to ask you now this. Okay, let me explain categorical first before I ask. Now, categorical data are data that you cannot perform aggregations on. You cannot perform aggregations on them, but you can categorize them. Look at this one. Let's start with the name. You cannot perform aggregation. You cannot get the total name. You cannot get the average name. You cannot get the maximum name, right? So you can't perform aggregation here, but you can group this name. You can categorize them. You can see all the people that are answering Grace Lee. It's possible to have more than one Grace Lee in this class. Two students can bear the same name. So you classify them, you categorize them. Let's say country now. I think it will be easier to explain with country. Country is not quantitative because you cannot calculate anything here. However, you can categorize country. You can bring out all the students that are from Ghana. You can bring out all the students that are from Ghana. You can bring out all the students that are from Nigeria. You can bring out all the students that are from South Africa, right? So this one is categorical. You can categorize them. You can say all the students from Nigeria, from NG. You can say all the students from Ghana. You can say all the students from South Africa. You can categorize them. So you cannot bring, maybe you want to bring out all their names, or you want to bring out the total number. You can just count 1, 2, 3, 4, 5, 6, 7, 8. So you can see that 8 students comes from Nigeria, and then you can do for Ghana and others. So you've categorized them. It is categorical. The same thing here. You can categorize all the students that scored A, all the students that scored B, all the students that scored C. That is the meaning of categorical data. So most data that you're going to be using are either categorical or quantitative. Now let's look at the zip code. Look at this zip code and let me know which one does it fall into. What kind of variable is zip code? Is it a categorical data or quantitative data? Are you there?
It's a quantitative data, sir. I think
Quantitative.
the
Yes, sir.
quantitative.
It's quantitative.
Quantitative.
Yes, quantitative, sir.
Can you give me your reason why?
Quantitative.
The reason being
It's
that we can
calculated.
It's categorical.
It's categorical.
Yes.
Why? Why?
It can only be categorized. You cannot perform
Exactly.
allegations on it.
Exactly. Because
Code.
zip code, I purposely put this zip code here
Yeah,
so that I will ask this
That's
question. You
possible.
cannot perform aggregation. You cannot get the total zip code now, even though it's number.
No
Can you?
way, that's crazy. Don't get embarrassed by me now.
So you cannot get the total zip code, right? You cannot get average zip code, even though they are numbers. These are numbers though, but they are not that kind of number. You cannot come. This is number. These are numbers, but these ones are code, just like your student code or ID, something like ID. These are not actually. If you classify them as data type, the data type is this one now is classified as number. These are numbers data type. But this one is not number. This one is, they call it a voucher. This one you can classify it as voucher because it is not number. You can't perform aggregation. But you can categorize it because this zip code now, 10001, many students can come from this same zip code. Maybe 2 students in Ghana can come. Maybe this is Accra zip code. So it's possible that many students, if you have more numbers, we have up to 1,000 students here. A lot of students will come from Accra, and all of them will have this same zip code. You can categorize all those students into one zip code. So this is categorical data, right? And it is not quantitative, okay? So please take notes. Now let's go back to our slide. So now that you understand categorical data and quantitative data, let us now talk about visual encoding. This is very important topic because this is now the basic of your visualization. Experts and researchers have determined the type of visual pattern that allow humans to best understand certain information. In general, humans best understand data encoded with position changes, difference in X and Y. So this is how graphs are being plotted. Visual encoding. So because of this thing now, because it is difficult to really understand this table, like it will take more time to understand this table, that is where the graph now comes in. So you can encode this information. Maybe you want to know this country now, you want to know how many students come from Ghana, how many students come from Nigeria. This is now where that visual encoding comes in. Let's say, let's now put this in a map. Let's put it in a column. Oh, This is not working. Let me use this one. Okay, you see. So this is now where the this thing comes in. It's not giving me what I want. I don't want to create. Anyway, let me just create it. I didn't want to create a pivot table for this, but let's do that. Since this is that, let's now see for country. Look, this is country. I'll put country here, and I'll also put country here. You see? So now we know the number of students that come from each of these countries. Let's try to visualize it and see and understand visual encoding. So this is what we call visual encoding. So we try to put, this is the x-axis, right? And this is the y-axis. Sorry, this is the y-axis and this is the x-axis. The x-axis is the horizontal and the y-axis is the vertical, right? So when you encode it, you put one information in the x-axis and put the other information in the y-axis. Then you match both information. Then you use what we call positional. If you now look at Canada, you want to check the number of students that come from Canada, then you now check, you put Canada in the x-axis, then the y-axis, you put the number, you want to check the quantity. So you can trace from this 0 down here. When you trace it to this first line, you can trace it to the y-axis, and then this point gives you, I think, let me use another type of chart. Let me use another type of chart to explain this thing, because this one will not explain it well. Let me use insert. Let me use scatter plot. Here, this is the best. This is scatter plot. This is scatter plot. So you can see, but scatter plot is not really showing. Let me see. Let me see. Let me see the age. Will it work? Okay. This actually worked though, but it's gonna be too advanced. Let me fall back to this one. So, but just to understand what I'm saying, you can see how this is being traced. You trace Canada from here. When you get to this one, you stop and see that, okay, you've encoded it. This is the position where the y-axis and the x-axis meet. It means only one student come from Canada. Then when you come to Ghana, you pass 1, this is 1, you pass 2, it is still going, you pass 3, it is still going, 4, 5. You can now see that 6 students, because you can trace it down to this 6 here. So this is the y-axis and this is the x-axis. It is called visual encoding. This is how graphs are being generated through positional, through this visual, what is it called? Positional encoding. Because when you trace it from here to here, you can see that the meet here, that helps you to know that, okay, 6 students come from Canada. Then from Nigeria, you can see that the graph went up, the chart went up to this point to 8. This is to tell you that 8 students come from Nigeria. 8 students comes from Nigeria. And the same thing with South Africa. You can see that 3 students. So these things are not just magic. They are not just generated magically. It is through what we call visual encoding. It is coded. You put the x-axis, you put the y-axis. Where they meet is where they know. That is where the visual tells you. That is where you read your information from. So this is how visual encoding helps you to visualize your data. It is the same thing with every other graph you use. All the graphs you're going to be using, they definitely have the x-axis and then the y-axis. Do you understand visual encoding? This is how it is coded. This is how these things are generated through the x-axis and the y-axis where they meet. So this thing can also be a straight line. You can use a line graph. Even if you use line graph, it is still exactly the same thing. Let me show you. Let's say we want to use a line graph here now. You can see that Canada, you're still going to trace it. You're going to trace Canada. This is where Canada is. It is 1 from beginning here down to 1. This tells you that only 1 student come from Canada. If you now come to Ghana, you can trace Ghana up to this point and trace it down to the y-axis. You can see that only 6 students come from Canada. If you come to Nigeria, you're going to trace it up to this place, then you trace it down to the y-axis. Where they meet is where the number is. This is where your visual is, which means 8 students come from Nigeria. The same thing with South Africa. You can see that 3 students come from South Africa. So all the graph you're going to be using are actually rooted in this visual encoding, right? So this is basically all about visual encoding, and this is how these graphs are being generated. This is expert and researchers did their research many years ago, and they discovered that this is the best way to represent these informations. Then visual encoding, I want to quickly talk about this then, because this is now where your graph comes. This is now where you select the kind of graph you use through visual encoding. So we have the univariate visual encoding, the bivariate visual encoding, and the multivariate visual encoding. What is the univariate? Univariate simply means when you're visualizing just one variable, like you're trying to just get one data out of the table and nothing else. What we've done just recently is univariate. So univariate is when you're considering just one. Yeah, go ahead, Cindy Way.
Hello, sir. How are you?
I'm good.
Yes, sir. I'm concerned here. What is the difference between the KPI and the variables?
What did you say?
What is the difference between KPIs and the variables?
Can you hear me? Hello,
Yes,
can you hear
sir.
me?
I hear you.
Okay, what did you say, ma?
Let me.
Hello? Hello?
Difference between
Please, can you come
KPI.
again? Your voice was breaking. Can you come again? What did you say?
I said, what is the difference between KPIs and the variables?
Okay. That's a good question. KPI is like a question. KPI is your key performance indicators. Key performance indicators simply means the things you're looking at, the data you're looking at, or let's call it questions you're trying to answer, or the key focus, the key data you're trying to bring out from this information. What your variables are, the data you're seeing here, these are the variables you're seeing, the information in your data. Like the table, let's call it column. Each of these columns are variables. This name, all these names are variables that you're considering. So KPI is like the answer you're trying to provide from this data after you finish analyzing, or you're going to use your KPI to analyze, to bring out the report or the information, while the variables are the thing you're going to be using to analyze, which is the data itself. As we go on, you're going to understand better. All right. So we are talking about visual encoding, and I'm trying to explain univariate. Whenever you hear univariate, bivariate, and multivariate, the univariate simply talk about when you're trying to get your information from just one variable. Now, this is a variable, right? This is a variable. Now, we want to know each of this country. How many students come from each of this country? I am just going to use only country, just one variable to get this information. I don't need any other variable. All right. And to do that, I'll come here. You can see how I got it. I just want to know the total number of students that come from each of the countries we are looking at. So I'll use country column, put it here. And I'll still use country again and put it here. You can see I used only country, one variable, to get this data. I can now see that one student came from Canada, Six students came from Ghana, 8 students came from Nigeria, South Africa, and then Uganda. By using just one variable. All right. Why the bivariate talks about getting your information by using 2 different variables. So if I want to get the age of students from each of these countries, age of student, total age of, okay, scores of student, let's know which country is performing better, right? So I can now say, okay, I want to insert a pivot table or a pivot table, whichever one. I can now use, when I want to do bivariate, okay, let me title it here. Univariate. This is univariate data. This one gives us univariate. We want to just get the country. I'll use only country. I'm using only one column. This country, remember, this country is only one column. I'm using to get this data for univariate. Univariate. Then let's do bivariate. Bi in normal English means 2. So for bivariate, let me use the same one. Good. So now bivariate, I want to get the score of students from each country because I want to know which country performs better or which country performed better. So I'll put country here, then I'll put scores here. So I can see that student from Canada scored 90. Student from Ghana scored 490. Student from Nigeria scored 691. Student from South Africa 24. So I can now know that Nigeria is a winning country. Nigerian students scored higher. Nigerian students scored higher, right? So here you can see that I use 2 different variables. Where is our data again? Here. So to get that information, I used the country and the scores. 2 different variables. It is by. Whenever I hear by, you're talking about 2. So univariate uses one variable to get the data, the graph or the chart, while bivariate uses 2 different information or 2 different variable to get the information. Then for multivariate is when you are now using more than 2. Anything more than 2 is multivariate. Anything more than 2 is multivariate, right? I'm just trying to rush so that we can cover everything. So univariate uses just one variable, while bivariate uses 2 variables. Multivariate uses 3 or more variables. So when you are now trying to get 3 or more variables, maybe from this our data set, let's see what we can get. If we want to get all the students that are from each of these countries with these scores, all the students from these countries with their scores, we are not or we can even get the ones that got their grade as well. As long as you're talking about more than 2 different variables, then you are talking about multivariate because you're looking at, give me the name of students from each of their countries with their scores and grade. So you're talking about multiple variable. You want to show multiple variable in your graph. That is when you now talk about multivariates. Do we understand this, please? I know it's quite a lot, but this is nothing. You don't need to cram any of these things. You're going to get used to all of these things once you begin to use Power BI. All right. Can I proceed? Do we understand multivariates, bivariates, and it's part of visual encoding? Can we proceed?
Yes, sir, we understand.
All
Yes,
right,
we
great.
can.
Great. So let's now look at multivariate. How do we represent multivariate visualization? How do we visualize it? When you're talking about multivariate, categorical variable and quantitative variable. If you're talking about univariate, just one information, I think I've already represented itself. Most of the times you're going to use bar charts and pie charts. All right. So to represent data for univariate, you're going to use the kind of charts, the best kind of chart to use is usually bar charts. Here now, look at this one. There's no other kind of chart you want to use here other than bar chart and pie charts. All right. So the bar charts here can help you represent this information at a glance. You can come here now and let's put a chart. You can come here. This is the bar column chart, column bar chart, or this is the bar chart. Column chart and bar chart are the same thing. It's just slant. The other one is straight. The other one is slant. So here you can see that one student come from Canada. 6 students come from Ghana. Like this is there's no other way to represent this information other than this bar chart because it's a what is a univariate categorical. All right. So each of these bar, you can see that each of these bar represents each country. Canada here represents this one bar. This one bar represents Ghana. This one bar represents Nigeria. Each bar represents a country. So in the x-axis, you're using the country, while in the y-axis, you're using the number of students. Therefore, each bar, this is Nigeria bar. You can see here that Nigeria bar represents the students from Nigeria. And this is the total number of students from Nigeria, 8 students. So this is how you use this bar, this information, this data is categorical. If you're representing categorical information because you're classifying them according to the country they come from. You're classifying the students according to the country they come from. So it's categorical. Another way of representing this is through pie charts. But let's see when to use pie chart and when not to use pie chart because you can't just go and start using pie charts. Bar charts, when trying to visualize only one variable, which is univariate, then you have to use bar charts. So bar chart shows the category on one axis and with each bar representing category and the count. So one bar is representing the count while the other bar is representing the category. Look at the category here is the country. So this bar is representing the category, which is the country, and this side is representing the number of students in that country. So usually it is representing the count. This is the count of students or the frequency of students. It may not be students, it may be maybe something else that happened or something. So this is how you represent a categorical information. Then if you want to use a pie chart to represent a categorical information, it is still possible. You can use categorical univariate visualization. However, this is more suitable for relative frequency, showing how a category contributes to the whole. So you must not just use a pie chart anyhow. Now let's put a pie chart here. Let's see how it looks. Let's bring a pie chart. So this is a pie chart and this is a bar chart. Which one do you think represents this thing better? Of course, the bar chart. The pie chart also represents, because you can see here that Nigeria, here this is Nigeria, then Canada, this is Canada, which is the smallest, then Ghana, this is Ghana, this is South Africa. Each of the pie represents the category of information, but this is not what pie chart is made for. Pie chart is trying to show you the category, this category now, Nigeria, how Nigeria is relative to the entire data you're considering. So frequency, usually it is used to represent frequency. Sorry, percentage. It is used to represent percentage of percentage of that particular data or that particular category you're considering against the entire group. That is when you use pie charts. So pie chart is usually, the unit of pie chart is usually in percentage anytime you're using it. So pie chart is wrong. We cannot use pie chart for this information, but rather you're going to use bar charts to represent this categorical data. So the next one is going to be the quantitative variable. So when your univariate variable is quantitative, when it is in numbers, then you use histogram, something we'll call histogram. This is also suitable for a univariate visualization where each bar represents a range of value, unlike bar chart where each bar represents a category. A histogram is built for quantitative data. So this is a histogram and how to use a histogram. Let's say now I want to represent, let's look for the information we'll represent. Let's represent the score. Remember, we're still talking about univariates, and univariate is when you're talking about only one variable. So we want to look at the score as a variable. So we'll come here. Let's create a new this thing. Remove this one, remove this one. So this is the score. We put the score here in value. Oh no, sorry. The score here in value. So this score is in value, and there's no way to plot this thing in a graph. It's not even possible. So now look at what histogram is going to do. Let's insert a histogram. Let's come here. This is a histogram. Therefore, no, this is a histogram. Treemap. I'm looking for histogram. Sorry. Okay. Bar charts. This is a histogram. Okay. Okay, let's bring out this one. No, it's not. Okay. Histogram. Yeah, this is histogram. Thank you. So this is a histogram. Look at the magic here. So a histogram, you can use it to represent a unit when it is quantitative. Remember, we said that categorical, you have to use what? A bar chart, but histogram is trying to represent the score. But there's something a histogram will do. This is when we try to represent this thing. There is no kind of chart you can use to represent just this, because we are talking about univariate, just one variable. So the only way you can plot this score is you must be plotting it against students. Let me show you what I mean. So if I had score here and I had students here, you can now see I can plot it, right? This is very easy. I can use a column chart or a bar chart to plot this one. You can easily see which students score higher, but now this is not univariate, this is bivariate, because we're now looking at two different variables against each other. So, but we just want to use univariate. So this is impossible to plot. There's no way you can, no kind of graph except histogram. And this is how histogram handles it. So what histogram will do is, histogram will now group it for you to turn it into a categorical data automatically. Categorical. This is supposed to be a quantitative data, right? But histogram will turn it into a categorical data. So this is what he did. He just said from 68, he looked at the highest and the lowest. He saw that the lowest score here is 68. The lowest score here is 68. And the highest score here is 98, or maybe 97 point something. All right. So it will not take, you can choose how many bars you want here. You can adjust it. Let's say if you come here, you can go to axis. Let's go to more axis. You can come to more axis, number of bins. You can come here, you see it's just 3 here. You can increase it to 4 if you want. Let's say you want to do 4. You can see it's now 4. If you want to do 5, you can do as many as you want. All right. But this is now the concept. It will group them into different categories. This is 68 to 74. It will break them into different. So it will now group all the scores that are between 68 to 74 here. From 74, here now is from 74 to 81 here. From 81 to 88, it will group them here. From 88 to 95 here. This is how histogram handles it automatically for you. So it will take every score now that is between 68 and so anybody that scored 68, 69, 70, 71, 72, 73, 74, they are all here. It's to group them here. So this person is here. This 68, this 70, this 73 is here. This 68 is here. This all of them, anyone between 68 to 74 will be here. Then anyone between 74 to 80. So you see how histogram handled it. So histogram can be used to convert a univariate quantitative data into a categorical data. So this is it has gone into its categorical data now because it has categorized them. All right. I don't know if you guys get what I'm trying to say. Do you understand me? Are we together? Do I need to explain it again? You understand, right?
I do.
Don't understand.
You don't understand?
Yes, sir.
Okay, let's go again. Do you understand what we are explaining on univariate? You understand what univariate is? So univariate is when
Yes.
okay, good. Do you understand bivariate?
Yes.
Okay, great. That's nice. So if you understand univariate, you understand bivariate. Now, when you're talking about univariate, what kind of charts do you use to plot univariate information? You're considering just one column. So obviously you're going to use a bar chart to represent that or a pie chart. So you only use a pie chart when you are talking about the percentage of a particular category against the entire data or the entire variable. So you want to consider the effect or the students from Ghana against the entire variable here, which is the entire country, student from these countries. Now, how do you handle, and all these ones are actually for categorical data. If your data is categorical, that is when you talk about representing them with a bar chart, a column chart. Now, what if your data is quantitative? How, and you don't want to, because for quantitative data, you cannot represent them with one univariate. It's not possible. I can use only this country now to plot a graph. All I need to do is just to come here, then come to insert. Let me plot a graph. Where is this one? Column chart. You can see I can plot a column chart with it and see. And the column chart will tell me everything that I need to know. I think you did not get it right. Let me plot a country from here to here, Ghana. Then column chart. It's not picking the information that I want. But I think we plotted it here already. Here. This column chart, you can see this is just one information. We use only one country to plot this thing. Just put country here, put the count. This is going to give you the count. Then you're able to use it to plot a graph. But when it comes to the quantity or the score, these are quantitative data. You cannot plot them, but with the help of a histogram, you'll be able to plot them. but not like a histogram is going to, the histogram is going to convert this thing into a categorical data. Okay, let's just proceed so that I don't waste time. Maybe as we go on, you'll understand better when you rewatch the video. All right. So this is it. So when handling a quantitative variable, you're going to use a histogram. A histogram is going to automatically convert it to a categorical variable for you. Then, now bivariate, remember we are talking about univariates here. What kind of chart are you going to use for univariates? You can use a bar chart, a pie chart, a histogram. All these ones will handle the data for you very well. Now, let's talk about bivariates. What kind of charts can you use for bivariates? When you're talking about two columns, two categorical variables, when you have two categorical variables, you're going to use clustered bar chart and stacked bar chart. Let me try to see if I can explain this. So if I want to talk about the students and their country, these are two different variables, right? And they are both categorical. If I want to talk about the students and their grades, these are two different categorical variables. How do we actually handle this? Or we want to talk about two students. Okay, let's come to our pivot table and remove all these ones. So we want to talk about, let's talk about here. So we want to talk about two different variables. How do we represent them? So maybe we want to talk about students and their score. No, their grades. Students and their grade. So this is it. No, this doesn't make sense. Let's say students and their scores. Okay, students and their scores. Let's see if country can also work. No. Okay, here now you can see that these students from Ghana, this one from Nigeria, okay, it has just splitted this thing, the scores. I want to make this thing easy for you to understand. Let's say we want to look at students and their, okay, the country. Yeah, we want to look at the country and the age. The country and the age. So we can come here and see country and age. Does it make sense? Counts, okay. Nigeria, 160 something. Okay, another information. Let's say we want to also look at the grade. Okay. So this is two different variables that we want to put here. Okay, let's say we want to put, let me see what kind of charts we can use to do this. Clustered bar charts. Good. So this gives us the information that we need. I think we did this in part of our assignment. So you can see country, Canada. But you're looking at two different variables here. You're looking at the age of students from Canada and then the grade of those students from Canada. And from your legend here, you can see that age is represented by the blue bars, while the grade is represented by the yellow bars. So this is called a column chart, a stacked column chart. This is a clustered column chart. Clustered means you can have multiple bars representing just one information. So under Canada, you can see that we have the student's age and the student's grade. You can even have the student score. Maybe let's see. You can put the student score here. You see, We now have multiple bars. For Canada, you have 3. You now have 3 bars. For Ghana, you have 3 bars. For, just like that. Let's remove grade and see. You can see for Canada, we have the age. For Canada, we have the scores. For Ghana, we have the age and the scores. So you are trying to represent multiple, 2 different categorical data for one variable. I don't know if this is going to scatter your everything you've learned. Okay, but just know that you can use clustered bar chart. Now, let's see the difference between a clustered bar chart and a stacked bar chart. See this information, this same information now. Let me use another type of chart. Let me use the, this is the stacked bar chart. Look at it, stacked bar chart. These 2 information, they are the same thing. This is the clustered bar chart. This is the stacked bar chart. So you can see that Canada, this is Canada. Canada, for the age, you have the average age of less than 100. Then for the score, you have the score here as 100, less than 100 as well. For Ghana, you have this one as above 100. Then this one as, am I using, let me use age. Okay, let me remove age. Let me use score and grade. Let me see if that works. It doesn't make sense. It doesn't make sense. Okay, let me use the same age because those are the numbers we'll have. Or let me even use country. Let me put country here. Good. So we want to know how many students come from. Okay, so we want to know how many students come from Canada, okay? And we also want to know how many students come from Canada. We also want to know which other value can we add here now. Let's use score. And we also want to know their scores. Which country has the highest score? So we can put score here. It changes this data again. It's not giving me what I want. Okay. Let me use age and score. Okay. So I just wanted to point out the difference between a stacked bar chart and a column. This is a stacked bar chart. You can see that this is stacked onto it. This is the age of the student, this blue one, and this is the score of the student. So, and now if you want to use the clustered, this is the clustered, right? So you can see that one of the bar is representing the age, the other bar is representing the score. But in this case, one of this down one is representing the age, the top one is representing the score. So the score of the student, let's say from here to here is the age of the student, which is 20. Let's assume it's 20. Then the score of the student is from here to here, which is from 20 to 100, which is 80. That is the score of this particular student. This is just an assumption because this data is not making any sense. Maybe I'll look for a proper data set to analyze, to show you what I'm trying to say. But you can use, instead of, because normally you're supposed to plot this thing separately, you're supposed to have 2 graphs, one that has the age versus the country, and another one has the score versus the country. But instead of doing them separately, we put them in one chart, which is going to tell you that, okay, this is the age of the student from Canada and this is their score. This is the age of students from Ghana and this is their score. The same thing for Nigeria and other countries. Now, you can also stack them instead of separating them, having them separately. You can stack them on top of each other. Don't worry, when we now start using it in practice, you're going to appreciate it more. Let me not just really bore you because I don't want people to start sleeping. 2 quantitative variable, you scattered plots. You can use scattered plot to represent. Now, look at this other data that I have here. I haven't mentioned it. Look at this one. This one is showing the temperature and the units sold. So this is an ice cream company. Please, can you hear me clearly? Can you still hear me clearly?
Yes.
Okay. So
Yes.
this is an ice cream company. This ice cream company, so what they want to do is they want to know the quantity, the unit of ice cream they sell, depending on the temperature of the day. So they want to know, do people buy more ice cream when the temperature is high or when it is low? Is there any relationship or correlation between the quantity of ice cream we sell in relationship to the weather or the temperature of the day? So that's what they want to know. So when the temperature is high, do we sell more? Or when the temperature is low, do we sell less or do we sell more? So let's plot this thing. And to be able to plot this thing now, you can, because these two things are quantitative data. Look at them, two quantitative data. So when you are considering one quantitative and one categorical and one quantitative, now this is not quantitative data because it is temperature. Do you get? It is temperature. You're seeing number there. Don't assume that because I'm seeing number, it is quantitative. No. 30 degree, this is like degree of whatever. This is like degree. So it is not quantitative, it is categorical. So this is a categorical data. This is number. This is quantitative data. So let's plot this thing. You cannot plot this thing now with, you cannot plot it with bar chart or pie chart or whatever kind of charts. You cannot because it will not work. All right. So let's try it and see if it works. You come to, let's insert. Let's try bar chart. It's not even going to work because it doesn't make any sense. You see, it cannot work. But let's try this one. This is called scattered plots. When you use scattered plots, no, why is it not coming? Okay, let's see. Scattered plots. You can see we can use scattered plots. Let me try this one again. Let me try bar chart again and see if it will work. See, bar chart worked, but it doesn't make any sense. See what it's giving us. It doesn't make any sense at all. Like it's even using, we selected bar chart. Is this a bar chart? This one now turned itself to a what? A stacked bar chart instead of normal bar chart. So it's not going to make any sense. But now let's use scattered plots. This is scattered plots. We use it. Now you can see clearly that this thing worked. So using that visual encoding that we talked about, you can see that when the temperature, this is the temperature axis in the x-axis, and this is the unit sold in the y-axis. So you can see that when the temperature is 10 degree, we sold 1. Can you see? Let me bring it here. So when the temperature is 10, look at 10 degree, we sold 1. When the temperature is, when you move a little, you can see that here is around 12. Since here is 10 and here is 20, so in between, middle here is 15, right? Here should be 14, here should be around 12. So you trace it down to the x-axis, you can see that we sold 1 again. So when the temperature is 0, this is 0, we sold nothing. You can see nothing is sold here. It is very cold. When the temperature is 10, we sold 1. When the temperature is 12, we sold 1. Then we move again. When the temperature is around, this is like 14, 15, 16. So when the temperature is 17, this is 16. When the temperature is 16, we sold 2. When the temperature is 17, we sold 2. When the temperature is 22, this is 22, we sold 1. When the temperature is, sorry, we sold 2. When the temperature is 30, we sold 3. When the temperature is 50, we sold 5. When the temperature is 50 something, this is 52, we sold 5. Please, you understand how I read this scatter plot, this chart?
Yes.
Okay, you're following, right? Okay, good. So this is to tell this company that the higher the temperature, the more the unit sold. So if the temperature is cold, nobody obviously wants to lick ice cream, right? But when the temperature is high, more people buy ice cream, they buy more ice cream. So this company is going to be praying for high temperature every day. In fact, if they know of a way to bribe God to be increasing the temperature level, they will be doing that because it gives them more sales. Do you get? So that's how to read this thing.
Yeah.
That's how to read this thing. So let's proceed. So then another type of, when you're considering two quantitative data, you use scattered plot. So there's also a violin plot and box plot when you're considering one categorical and one quantitative. But this is more advanced. When we get to this point, you're going to Excel doesn't have this kind of charts, okay? But when we get more advanced, you're going to we are going to use it. The multivariate. We've talked about the univariate, the bivariate, the kind of charts to use, then the multivariate. We typically try to use position on X and Y axis to encode or depict the value of variable. If we had more than 2 variables, however, we have to start considering other visual types. So look at this one that we just did now, this temperature on. Let me bring it back so that I can explain what I'm trying to say. So now, this is the only way of showing this thing. Even when you're using bar charts, sorry, let me use bar charts here. Even when you're using bar charts, there is no other way. This is bar chart. There's no other way you can add any other kind of charts. So the only way now that you can add a third, because this is like bivariate. For multivariate, you're supposed to be adding like 3 or 4 more different kind of, but there's nothing else you can add here. The only way you can now add additional consideration is by maybe using color. You can say, okay, this is from Canada, or let me use this one, or because this one has gone out. Let me bring it back. I'm trying to show you how to use bivariates. This bivariate now, there's no other way you can add any other extra thing. It's impossible. So the only way to show bivariates here, since you've shown univariates here by showing the x-axis and the y-axis, you can now decide to show, maybe you want to show country, each of this country, that this one belongs to so country. This person that bought this thing is from so country. You can now change color. You can use the color. You can change this one to maybe red to show that this person is from Ghana. Then you can change this one to green to show that this person is from Nigeria. You can change this one to yellow to show that this person is from South Africa. You can change this one to maybe brown to show that this person is from Uganda. That is a third. You've introduced a third, or you can even change the shape. You can use shape, maybe triangle to show that this person is from Ghana. You can use maybe square to show that this person is from Nigeria. You can use a rectangle or a cycle. Or you can use size. You can increase the size. You say, okay, if this person is from Nigeria, the size should be bigger. Or if the person is from Ghana, the size should be smaller. If the person is from South Africa, the size should be maybe. So that is how you introduce the third. That's the multivariate. The third, because you cannot add any other kind of, you already use the Y and the X encoding that we talked about. So the only way to do the multivariate, the third one, is to add color, size, or shape. Do you get?
Yes.
Okay, great. So now let's talk about, this is the last thing we're going to talk about tonight before we close. And this is the most important part of this class. I'm going to be very fast about it because I was going through your project and it was really beautiful. A lot of people did excellent work. In fact, we designed very beautiful dashboard, but when I looked at those dashboards, some of them do not have any data inside. It doesn't have much information because you focused on designing a very beautiful dashboard. When you're not a UX, UI designer, you're not a graphic designer, you are trying to design a dashboard. So your dashboard should not have junks inside. Your dashboard should just focus on passing the information and not trying to color it or show how beautiful it is, because nobody cares about the beauty of your dashboard. So what are junks that you should avoid? Chart junks. Chart junks refers to all the visual elements in chart and graph that are not necessary to comprehend the information being represented on a graph, or that distract the viewer from the main information. So when you build your dashboard and it has so many colors, these are some of the examples of chart junks. You can have a heavy grid line. So when you have a heavy grid line, it is a chart junk. It is totally terrible. Like, look at this chart now. Remember when I used to remove this thing. When you remove this now, look at how beautiful the chart is going to look. When you remove this grid line, just come here. Let's say we delete. Why is it not deleting? Delete. Okay.
No, click on this.
Eh?
Click on that plus sign that is added.
I wanted to just. It's also possible to delete like this. I don't know why this one is not working. Okay. So if I remove this grid line, you can see how simple and clean this chart is. But if I don't remove it, some people even go as much as coloring this grid line, like making it bold, just to make or coloring it, putting it in style and making their chart look so beautiful. So you don't need that, because we are not interested in this thing. We are just, this is the data here. These bars you're seeing here, these are the data here. That every other thing here is not necessary. This is the only information. This, we want to know that this bar represents Canada. You want to show us the number of students from Canada. That is all. That's nothing else. We are not interested in your colors or your heavy grid lines on that. So avoid heavy grid lines. They are not, is a no. Unnecessary text. You also remember how I was removing text. I removed almost everything here and left only the necessary ones, and make even these necessary ones, you make it as short as possible. All right. You saw when I removed this one, we remove all these things because they are not necessary. So you don't want to have is a junk. You don't want to have it in your dashboard. You want your dashboard to be extremely clean. You don't even want pictures. Don't bring pictures. Some people will go ahead and they want to make their dashboard so beautiful. They want to bring pictures and be putting in their dashboard, within the dashboard. You don't want to have pictures, unnecessary pictures in your report. Some people even add GIF in their reports. So you don't want shading or 3D components. Don't put 3D. I also saw that some of you went ahead to use pie chart. I don't know what pie chart was doing in that project. I didn't expect it. And some people did not end up in just using pie chart. They also use 3D pie charts, which is the worst thing to ever do. Try as much as possible to avoid pie charts in your chart, except if you are representing percentage of a unit against the total. If you manage to use pie chart for any reason, avoid 3D pie chart. A lot of people use that. I was wondering why. This is a junk. Ornamental chart axis. So ornamented, you don't want all those coloration, all those beautiful. No, you're not doing graphic design. So data integrity, I also want to talk about data integrity. It's very important. It's key that when you build plots, you maintain integrity for the underlying data. One of the main ways we will discuss here is, okay, look at data integrity is with a live factor. So data integrity is simply talking about making sure that the data that you're presenting is what it is. Don't try to add or remove from your data. Make sure you're giving exactly what the data is giving you. Shortly, I'll show you a picture to explain this further. Then using colors, please don't use colors. If possible in your dashboard, if possible, try as much as possible to use just black and white only. I know you want a lot of people use a lot of colors on God. If you see colors that I saw in your dashboard, some dashboards, you'll be amazed. Some people want to beautify. No, those colors are not necessary. If possible, stick to just black and white. And when we start building dashboard, you're going to understand this better because it is people are not interested in those colors. They just want to see the data and go their way. That's all. When using color, use less tense colors. Don't go and use red, green, all those heavy colors to beautify your dashboard. Color for communication. Use color to highlight your messages. So sometimes you may want to use colors, but for example, maybe you want to point out the highest, this one now that is highest, maybe you want to use green because this is Nigeria. So at a glance, they can see that Nigeria has the highest. You now come here and use red. You now come here and use white. You now come here and use yellow. It doesn't make sense. If possible, use just one color for all of them. But if you want to point out that Nigeria has the highest, you can use, if you want to use green for all of them, for example, you use green for all of them. But when you get to Nigeria, you can make it more greener, like the green should be more. Then for Canada, the green should be faint to show that this one is the smallest. It will still maintain the same color across all of them, except for situations where you want to use pie chart. Normally, pie chart you have different colors as well, but there's still a way you can maintain the same color gradients in pie chart to make your work really good. So coloring is a very important, as important as the data itself. All right. So make accommodation for colorblind people. So colorblind people, they don't like green, red. You cannot put green and red together in the same place, side by side. They will not see it. They will see it as a different color. I'm going to show you shortly. Just be with me. All right. So don't put, always be mindful. Just stick to black and white if possible. But I know it is not possible to stick to black and white. But however, always put these people into consideration because they are not able to see red, green put side by side. So look at some of the chart junks that I just brought up. So this chart junk, how do you feel about science? Now look at it, chart junk, this is not looking good at all. This is like rioting, colors, different colors. You can't even tell. Look at this one, this one. So there's a way you can blend these colors to maintain the same color across them. So this is really bad. This is so bad. Then look at this one. Somebody used this actually in their project to use. Now, let me ask you now, which one is the highest pi here? Now, let's see. Which color here is the highest? Let me see. Who can tell us which one is the highest here? The biggest one here, sorry. From which just
that should be the yellow one.
the yellow one, right? That is B.
Yeah. Yes.
Yes, this is an assumption though, but I know the data that this was gotten from. From the data, this brown one is actually the biggest one. So, but because this is a 3D image, because 3D image you try to the one that's closer to your eye will look bigger. But the one, like this is how 3D work. The one that is closer to you will look bigger. Then the one that is farther from you will look smaller. But in the real sense, if you turn this to a normal pie chart, you're going to see that the brown one is the biggest one here. And this is the second biggest, and then this third biggest and fourth biggest. So always avoid this 3D, using 3D. You're not designing a graphic or UX, UI. Avoid 3D. It is not acceptable at all. Then look at these two now. These two things, you can see, if they ask you, you can see that this red one, this orange one is bigger than this one, but they are both 28%. They are actually the same size. But because of the way they are positioned, you can see that this one is smaller than this one, but they are both the same size. None of them is smaller or bigger than each other. So you want to avoid using such thing in your graph. Then look at, I just highlighted all of them. Look at, avoid heavy and dark grid. Don't go and use grid line. Unnecessary text, remove them. You don't need all those text. Then pictures around, don't put picture, don't even put picture at all in your graph, in your design. Then shading or 3D component, I've talked about that already. Don't use 3D. Look at what I'm trying to say. This is an example, a perfect example. This person is trying to beautify this is actually beautiful, I must say. It's very beautiful because the coloration and everything. But this one has no information. Like, this is not what we're here for. This one has background, they added background color, they added shading, they put text on top, did everything to look good. But this is the actual one. This is where it should be. Remove unnecessary things. Just focus on the data alone. Because if I come here, first of all, I will struggle first. I'm trying to know what. Even if you're not there, someone should be able to read your data and get information from it. So from here, the person will be distracted. They are looking at color first of all before they will find the data that they are looking for, which is wrong. Then look at this one. When you talk about data integrity, this is what I mean. Now, look at these two bars. This is 35% and this is 39.6%. The difference between these two bars is just less than 3%, right? It's less than 4%, I think. Yeah. It's less than 4%. 4.4 bar?
4.6.
4.6, okay. So normally, because the difference is not, this is supposed to be maybe around here. But due to lack of data integrity, they bloated this one. This is false. They're trying to show false information. It is very, very misleading. So this is very wrong. You cannot do this. How they achieved this was because they are supposed to start this thing from 0, but they started from 34%. You can see this is 30. Should be around 32%, 34, 36, 38, 30, 40. That's how they bloated it. So this should have started from 0. If they have started from 0, this should be close to this. This should be around here because 35 is not far from 39. They are very, very close. So this is lacking data integrity and is very, very misleading. It's misleading. Always avoid that. Then I'm trying to show you here the effect of 3D. This is 3D chart, 3D bar chart. So you can see that it doesn't make any sense. The person even tries to use background, color the background, add some other pictures just to make it beautiful. Yes, it's quite beautiful. There are different colors here. So always try to avoid using different colors for your charts, for your bars. You can see the person uses different colors for their bars, which is wrong. This is the correct one. In this correct one, you can see at a glance that this French fries has 600, potato chips has 550, then beacon. So they highlighted this beacon so that your eye can go to this beacon straight because I think they want to point out something. The data is about this beacon, this bacon. Then the pizza has 400. This is very straightforward and clear. At a glance, you can just see the data straight up. But here you struggle very well to see the data that they're trying to make you see. And then I talked about the colorblind people. This is how colorblind people see colors. When you put green and red side by side, this is how they read it. They tend to see it as this color, the same color in their eyes. So you want to avoid using red and green side by side. Then this is it. When you put red and green together, it doesn't work for them. It doesn't work. They see it as the same color. But always try to, use these other variants of colors, different variants of colors. It will work. All right. Then and that's it. That's basically it. And I think we'll stop here. We're already far gone in our time. So in our next class, we are going to talk about start properly. Now we're going to jump into Power BI and start our visualization with Power BI. All right. So guys, thank you. This is the end of our
Thank
class
you.
tonight. We're going to stop here because a lot of people are sleeping already. I can see that. And it's okay. It's okay. So is there any questions so that we can call it a night? Any questions, please?
No question.
All right, no question. In that case, I will see you guys in our next class on Tuesday, right?
Wednesday.
On
Wednesday.
Wednesday. Oh, Wednesday. Yeah, sorry. On Wednesday. So please, I hope you have all downloaded your Power BI desktop.
Yeah.
Yes,
Is anybody having any
Yes, I've
challenge?
downloaded mine.
Okay. So no challenges, huh?
No
no
challenge on it.
change.
All right, good. So we'll see you on Wednesday. Then we'll start properly. We'll jump into the Power BI and start our visualization. All right. Good night, everyone. Bye. Have a
Good night.
beautiful
Thank
day.
you very much.
Thank
Yeah.
you.